Hi, welcome to BC Video 9.10b Part 1, more on special series and creating series from them. Okay, so to approximate ln2, if they don't tell you which Taylor polynomial to use, which Taylor series to use, you could either use lnx near e because 2.7, or you could do it near 1, obviously. 2.7 would be better because it's closer. Okay, so if you do it near e, so your original function is ln x, take the derivative, 1 over x, take the derivative, etc., etc. Now you're plugging in e, your a is e, ln e is 1, e to the negative 1, etc., etc., etc. So you could say it is ln is equal to 1 over 0 factorial x minus e to the 0 plus 1 over e over 1 factorial, etc., 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 which would give you ln of x is 1 plus x minus e over e, etc., etc., and therefore then you could replace the x by 2, and therefore it would be 1 plus 2 minus e. You just replace all the x's by 2 and then use a calculator. If, on the other hand, you did it near 1, then you have ln of 1 is 0, 1 to the negative 1, 1 to the negative 1 to the negative 2, etc., and that'll give 0 over 0 factorial x minus 1 to the 0 plus 1 over 1 factorial x minus 1 to the 1, etc., etc., etc. And so if you wanted to use that to approximate ln of 2, then you replace all those x's by 2's. Now, as far as tan x, if you have tan x, you could differentiate tan x to get secant squared x. If you have tan x, you could integrate tan x to get ln of absolute value of secant of x. Keep in mind that sine of x squared, nobody can do this, but we are going to be able to approximate the integral from 0 to 0.13. My God, that does not look like 0.13. Let's try that again. Blue. 0.13. Okay. So we'll start with sine x, which we should know. Hopefully, remember, sine x is an odd function. And then we'll replace x by x squared. And now we'll have the sine of x squared. So I'm replacing all these x's by x squared. And I do the same over here. I replace the x by x squared. So I have x squared to the 2n plus 1, which is x to the 4n plus 2. And as a check, remember, make sure your first term does equal x squared. And that's going to happen when n is 0. All right, now we're going to integrate. Now remember how we write this is we write it 0 to x of sine t squared dt. It's kind of an interesting thing, but we replace the x by t and integrate from 0 to x. So what happens now when we do this is we're going to integrate each term, x cubed over 3, and this will be x to the 7th over 7, and of course you already had a 1 over 3 factorial, etc. Okay? So that will look like this. Do not bother expanding that. It'll be easier for you to get this. Now this is interesting because over here, this is your constant, the green. Here you're going to integrate x to the 4n plus 2, which will give x to the 4n plus 3 over 4n plus 3. And now we're going to replace that x. Remember we had over here, we're going to replace that x by 0.13. So what happens is, and by the way, just so I can explain to you about the t and the x, if you were to evaluate that from 0 to x, if you had all t's here, let's say you had all t's here, because you'll have, t cubed over 3, that would replace them all by x's, you'll get this minus, and when you replace them all by zeros, that'll just disappear. So we're going to replace our x up here by 0.13, which means we're going to replace all these x's by 0.13, and that would give you an approximation. Okay, so here's my explanation of the t's and all that. So sine of x squared would equal this. Sine of t squared dt would just equal this. So the sine of t squared dt from 0 to x would be that expression from 0 to x. But then you'll replace all those t's by x's minus replace all the t's by 0. Since it's a polynomial with no constant term, these will all be 0. So that's why this gives this. Okay? All right, page 687, numbers 1 through 11, use the definition of Taylor series. for now you could use this table, or if you've memorized them, to find the Taylor series centered at C for the function. Okay, so this one you have to use the table, although you know the formula for e to the x, you only know it for near 0. This is near 1, so you actually are going to use the table here. So here's your various derivatives, of course, but now we're replacing the x's by 1, and therefore we get this expression right here. Which then and this is the interesting part, you're actually going to look at this and get this summation notation by observation. So you're going to notice that you have x minus 0, x minus 1 to the 0 to the 1 to the 2 over 0 factorial, 1 factorial, 2 factorial, and there's an e in front of each one. Find the Taylor series for f of x equals tan x centered at 0. Let's just do the first two, because look at how ugly this gets. Derivative of tan is secant squared. Derivative of secant squared is 2 secant x times secant x tan x, and then you have this horrendous product rule, and you can imagine how it gets uglier. At least we're doing it at 0. The tan of 0 is 0. The secant of 0 is 1 squared is 1. This is going to give 0 times 1 times 2, which is 0. This will give 1 times 2 times 1, which is 2, plus 0 times who cares what. So we get 0, which is our x to the 0. It's the numerator of the coefficient of x to the 0. This is the numerator of the coefficient of x to the 1. So it's 1, x to the 1 over 1 factorial. Then there's 0 x squares, but x cubes, there's 2 over 3 cubed x cubed. So that's near 0, and therefore that gives x plus x cubed over 3.